Hello friends, you all are welcome in our Scala learning journey. This is third part of the main topic class parameters and constructors. Here in this tutorial, we'll discuss private fields and methods in class. So private members in a class are only accessible inside the class methods, not outside. We can define any members of a class as private by using a private keyword. To understand private members usage and its significance, let's move to coding and implement it in our existing class fraction. Here we have already created in our previous tutorial a class fraction which has methods with operation of addition and subtraction, and they return an object of type fraction. Let's introduce two more methods, multiplication and division. They will also return an object of class type fraction. Let's create two more methods, definition multiplication. This will also take parameter of type fraction, and it will return also fraction type object, and its implementation will be similar. Multiplication is just, it will return a new fraction with the multiplied numerator and denominator. So we'll multiply directly with numerator, with this class numerator with the passed fraction numerator, right? So that dot numerator, this will be the numerator, and the denominator will be denom, multiplication of that denominator. Okay, so this will be our implementation of multiplication. Let's create a division method as well. So here we'll provide the name as division. How we divide? We multiply the numerator with the denominator of another function, right? That is how we perform the division operation, and the denominator of this will be multiplied to the numerator of another. So after creating the division method and multiplication method, let's create an object of new fraction type, and here let's change the numerator and denominator value. Let's make it 3, 5, and let's make it 5 and 9. Similarly, let's make another var z, define another, create another object and store that reference in variable z, fraction type, and let it be 6 divided by 15, right? So just comment out these all, don't need it. Okay, so here we have created a new object of type fraction. So we have created three fractions x, y, z, and let's perform the multiplication operation. Let's create a variable result. So of object x we'll call multiplication method, right? And multiplication method takes argument as a type of another fraction, right? So let's pass y over here. So this will be resulting into another result will be a it will hold a object of type fraction which will hold the numerator and denominator after multiplying x and y. Let's execute this one. Let's run it. So here we got the result value, right? 15 by 45. So in result we got, when this x dot multiply y, when the multiplication method is called of x object, right? So it returns a new fraction. So when it creates a new fraction, when it creates a new object, this whole class is executed as a constructor. So that's why when we call this x dot multiplication y method, so this println statement is executed, and that's why we get the fraction is 15 by 45. We don't have to write separate println statement for that. So this is 15 by 45, but this is not normalized, right? The normalized form of 15 by 45 is 1 by 3. So let's introduce another method, greatest common divisor, which will find the greatest common divisor between two integers and can be used for normalization of fraction. Create that GCD method. It's created over here only, def GCD greatest common divisor, and what it will take two integer value of int type, and it will return an integer, And what would be the implementation of it? GCD implementation will be that in A we'll pass the numerator, in B we'll pass the denominator. So A divided by B, what would be the reminder? That reminder will be divided by that reminder will divide the B. So this will be a recursive function. We'll pass B and then comma A, then what? The remainder of A division of B. So A percentile B. So this would be the implementation. How this would work? Let's take an example. Suppose we have 15 comma 9, two numbers, right? So what would be the greatest common divisor of it? How we will find it? The formula is that divide 15 by 9. So what is the remainder? 15 by 9. Remainder is 6, right? And the divisor is 9. So 9 will be divided by the remainder of 15 divided by 9. So always the this divisor or denominator, whatever you say, that would be divided by the remainder of the previous one. So here remainder is 6 and the denominator is 9. So it will 9 divided by 6. So what would be the remainder? 3, right? So 6 will be divided by 3. Now what is the remainder? 0. So whenever we get 0 remainder, so we will take the divisor, right? What was the divisor? That as the greatest common divisor. So here GCD will be equal to 3. So what we will pass in the remainder section will be A divided by B, that is the remainder over here. So we will pass over here, and this B, the denominator or divisor, will go over here. And what will be the terminating condition for this greatest common divisor function? If so, whenever B equal to 0, so whatever has been passed in A, that will be the value. Else we'll call this recursive function. So in recursive function, let's understand one more concept, right? Here we have given int. Suppose we don't give any return type, so it should be type inferred. You have seen, right? But it has taken any, not int. So in recursive function, Scala cannot infer what would be the return type of the recursive function, because it will go in loop. It will always call, it will refer GCD to find the return type, to infer the return type. So again, GCD method internally, what it is doing, it will get confused, right? It is again calling itself. So it will go in a loop. It will not be able to infer what is the return type finally. So we have to explicitly provide in this condition. So we know that the return type will be the terminating condition, right? That will be A. So A is what? A is int. We'll give return type as int. And let's take a variable GCD method, and the arguments pass will be n comma d. Fine. So now what we'll do, let's take it. Let's write it like this. So this numerator, this n, will be normalized and divided by g, greatest common divisor. Similarly, denominator will also be divided by g. So now we'll get the normalized one, right? Let's introduce one more println statement to see the value before normalization and the value after normalization. So let's execute it and see whether we are getting the normalized value or not. So earlier we got 6. See here, 3 by 5 is normalized, 5 by 9 is normalized, 6 by 15 would be normalized to 2 by 5. And similarly, 15 by 5 will be normalized to 1 comma 3. Let's run this. So this 6 by 15, right, before normalization. After normalization it is 2 by 5. 15 by 45 after normalization it is 1 by 3. So we have seen how greatest common divisor works. But you must be wondering, like, we have not introduced what is private variable methods concept over here, right? So the significance of private is like, suppose this is GCD function. This GCD function doesn't make any sense if we are using outside, right, of this class. This is the inherent method of this class, where it will normalize whatever n or d is used, right? So it should not be visible outside of the class. Suppose we have created an object xyz, right? So if we give z dot, GCD, and we pass over here 6 divided by 15. So we can access, right? Similarly, we can access z dot g value as well. So we can access this and we can print it. So it will give 6 by 15 will give what? It will give 3. So similarly, but it's of no use, right? We don't want to make it visible outside the class, but it should be used whenever we are calling that, we creating that function. It should normalize it, right? Numerator and denominator. So how to make restrict that visibility inside the class only and not outside the class? So that can be done by making it private. So we can, by private keyword, we can make it this method as private. Similarly, this variable can also be declared as private. Now, after declaring it private, right? Let's see z dot. Are we able to see GCD? We have created an object of fraction type, but we are not able to access the this method of this class, right? Fraction, though we have created through its object. So that is the significance of private. Similarly, we are not able to see the G as well. It is giving error. It will give error. See, it is giving error, right? Now with the final implementation, let's run it. We are getting the normalized fraction, and we have created private members and variables, and we have seen how its usage is and what is its significance. So let's move to another great concept of keyword this, that is also called self references. So people have lot of queries and doubt what is, they get confused that what is the significance of keyword this. So let's see that. The reserved word this refers to the currently executing object whose method is being called upon. So mark these words, okay, whose method is being called upon. So this if you have created an object of a class, so it will have a state and behavior. So with this keyword we can use, the state means the variable of that class or object, and the behavior means method of that object. So how to understand it? Let's move to coding and take an example and understand it completely. So here we are in our same code class fraction. So we'll create another method called less than, so which will compare between two fractions and will return boolean value, the true or false. So it will compare two fractions. So let's create another method. Let's name it as is less than, and it will accept parameters of type fraction, and then it will return boolean value. It will compare between two fractions. So we'll write this dot numerator. So you must be knowing, right, how we compare with between two fractions. So this dot numerator into that dot denom is less than this dot denom into that dot numerator. By this we can ascertain that which fraction is smaller or greater, right? So we multiply the numerator with the denominator of one numerator of with the denominator of other fraction. Similarly, denominator of one denominator with the numerator of other fraction. So here this dot numerator refers to this numerator. I am selecting over here, right? So you can see this numerator. When I am saying this, the if we have we are creating an object x, suppose over here. So this is the numerator of object x, that is 3 by this is 3, and that is the, when we are passing the another argument, suppose we are passing y over here. Let's take an example and then understand. Suppose we have to check if x is less than what, y. Is less than is the method of x object, right? So here when we say this, then this is the numerator of x object, and y, when we say that, so that is the denominator of the argument passed to is less than method, right? So similarly, this denominator is the denominator of x object, denominator of this is when we say this denominator, then this denominator is there, right? So when we see that, so it is the argument which is passed to this method, so that numerator. Okay, now let's check what is the value. Run operation. So x is less than y, that is false. Yeah, x is actually x is greater than y. 9 3s are 27, 5 5s are 25, so 27 is greater than 25. So here we are saying x is less than y, that is false. So we got that, right? So you might be wondering why we have written this over here. Yes, just to explain you what is this. So it is equivalent if we write, suppose, let's take and let's comment this out. Write like this and just remove this. So this statement is equivalent to the other one. So it is equivalent to the below one. Okay. Now what scenario could be that where we cannot omit this? We require this to be included. We cannot do without this. So let's take another example where we cannot do without the keyword this. Let's take create a method called max. What it will do, it will also take parameter of type fraction, and then it will check whether it is less than that. So if it is true, so this is max method, right? So what it will return, if it is true this is less than that, then it will return that. Otherwise what it will do is it will return this. So here what it is doing, it will call this is less than method, right? And it will provide the argument that which we have provided in max. So it's evaluate to boolean. So if it is false, then it will return the max value, that will be that. Otherwise it will return this. So here this we can remove this, so then also it's correct, but we cannot remove this one. Why? Because if we'll remove it, then it will not return anything. So in this case, suppose that is smaller to, in this x is greater, right? So if we call this max method, let's call this max method, we'll take val greatest and x dot max. It will call max method of x object, and where it will pass y, right? So this will hold, greatest will have the reference of the max between x and y, right? So now let's print this greatest dot numerator and greatest dot denominator. So let's see what it gives. Let's run this. We got 3 by 5, right? So false. X is less than y, that is false. That means x is greater. So we should get x. So we got x, that is 3 by 5. So what is there in this, right? Whenever this max method is called on x, right? So here this is the reference to current executing object of which the method is called. So method max is of which object? X. So x is this is the reference to x. So what it is returning? It is returning this over here. So this is the reference to the x, the current executing object. It's not reference to y, because y is an argument to this max method, but current executing object is x, and this is a reference to x. So that's why this greatest will have the reference to x. So can we access the numerator and denominator with keyword this? Yes, we can. Let's see. We can access the numerator and denominator as well. So this completes our concept on self-reference keyword this. A quick recap of what all we have covered. We have seen the concept of private variable and methods of class in Scala, its usage and significance as well. We have also understood the concept and usage of the self-reference keyword this with the help of an example. Finally, this completes our entire broad topic of class parameters and constructors, which has 3 tutorials all in total. I'm confident that if you have completed all the 3 tutorials, then surely you have mastered some great and final concepts in Scala. Thank you.